So today's lesson is on identifying the different types of chemical reactions. And our goal is at the end of this lesson, we should be able to classify a chemical reaction as either synthesis, decomposition, combustion, single replacement, or double replacement. And so these 5 types of reactions have certain characteristics or patterns that they follow every single time. And what makes that useful is it then kind of gives us the ability to predict what the products of a reaction should be before we ever actually combine the reactants. And so it's nice because it lets you know what you're going to get, before you actually start. Now, this worksheet that we're kind of going off of today is either located on your Google Classroom page or it's found on page 80 of your lab manual. Typically, this handout is something that you all would complete on your own after the Unit 7 test, but today we're just going to work through it together. If you've already watched Lesson 8.1, then you're probably pretty familiar with this little background text on chemical reactions. So in short, it's just reminding you that in a reaction, you're taking substances as the reactants and converting them into brand new substances as the product. So that means you end up with something different than what you started with. We also talked about how when we're communicating about a chemical reaction, we'll typically represent it using a chemical equation, where we have the reactants on the left, the products on the right. The arrow is in between, showing the transition from reactants to products. And each of the reactants and products are followed by a state symbol that tells you what state of matter they're in: aqueous, gas, solid, or liquid. All right, so let's go ahead and jump down to the 5 different types of synthesis reactions. 5 different types of chemical reactions. The first reaction type being synthesis. And so for me, this word normally makes me think of a synthesizer, which is kind of used in the music industry to put several tracks or beats together into kind of one cohesive, piece of music or mixtape, something like that. And so the keys of identifying a synthesis reaction is you're taking at least 2 reactants and you're combining them to just get one product. So kind of in our drawing here, we have A plus B combining to form AB. And so your synthesis reactions should start with more than one reactant and end up with just one product. And so typically in your synthesis reactions, you'll have kind of just some simple elements like silver and oxygen, or hydrogen and water. And here again, we see them forming one product. All right. So now let's go ahead and talk about decomposition reactions, which are the reverse of a synthesis reaction. Now, in decomposition, we may think of food in this case. If some food has been left out of the fridge too long, or it's just old, it may start decaying or going bad. And so decomposition is the process of breaking down. So instead of ending up with one product, we're going to start with one reactant and break it down into more than one product. So again, this is the reverse of synthesis. Synthesis is coming together. Decomposition is taking one thing and breaking it apart into more than one. So in our example, AB is being broken down into A and B. All right. And so for our reaction example, we've got hydrogen peroxide being broken back into its elements, hydrogen and oxygen. All right, let's keep going. All right, reaction type 3 is combustion, and this is a reaction that we talked about in the balancing chemical equations video. And so the combustion reactions take the same format every single time. The reaction will start with a hydrocarbon, which is a compound that contains at least hydrogen and carbon. Then it will react with oxygen, and the products every single time will be carbon dioxide and water. And then again, energy is typically released in the form of heat and often light as a result. Okay, so here again we have a hydrocarbon, has carbons and hydrogens. It's reacting with oxygen, and it produces carbon dioxide and water. And so when you're looking for a combustion reaction, kind of the easiest things to start with is just look at the products. Does it make carbon dioxide and water? And is it reacting with oxygen? All right, now let's finish up with our last two types of reaction, single replacement and double replacement. And so the key to help you distinguishing between these two are going to be the words single and double. So in single replacement, what you're looking for is a single type of element by itself, okay? And what it's going to try to do is replace another element within a compound. So for example, we have substance A, kind of this red circle here. It's a single element by itself, and it's trying to replace element B, which is a part of a compound. So what happens, A and B will swap places. A will become part of the compound, and B will now be kicked out kind of by itself, which is the position that A had when the reaction started. And so if we trace that kind of in our written out example here, we have copper as a single element, and it looks like it's trying to replace silver, which is a part of the compound. So silver gets kicked out, and then copper then joins the compound with nitrate. So again, that single replacement, a single element replacing another element in a compound. Now in double replacement, the key here is that you're going to have two compounds swapping two of their parts, all right? So what will happen is you'll have ionic compounds specifically, and so the first parts of your compounds will be cations that are positively charged, and the second half of your compounds will be anions, which are negatively charged. And kind of as we see in the diagram, those pieces will swap to make two brand new compounds. So if we follow it here, we have Ag and Na. We're going to swap those pieces, all right? And so what that means is that Na, sodium, should now be paired with nitrate, which it is in the product area. And Ag, silver, should now be paired with iodine, all right? So that is the double replacement scenario where you have two compounds kind of swapping their pieces to form two new compounds. So now what we're going to have you do is kind of take some time to practice classifying the following chemical reactions as synthesis, decomposition, combustion, single replacement, or double replacement. And instead of me checking, we're going to post the answer key at the end of this video. That way you can check yourself. But to start off with, let's go ahead and do just a few of the practice problems together to make sure you're on the right track. So here we have number 1, and we have PbCl2 plus silver nitrate yields lead 2 nitrate plus silver chloride. All right. So first of all, what we want to analyze is, what types of substances we have. So it looks like we have two compounds that are making two new compounds. So that kind of already has me thinking in my head that, oh, this must be double replacement. Two compounds making two new compounds. But let's check just to be sure that they're actually swapping their parts. So in the swap, lead should now be with nitrate, which it is, and silver should now be with chlorine, which it is. So we would classify this reaction as double replacement. All right, now let's try that next practice problem. Here we have two compounds that we're starting with, but we only end up with one product. Everything is coming together to make one new thing. So if we only end up with one product, that is a synthesis reaction. Everything has been brought together into one. All right, now let's skip down. Let's do number 6 right quick. So here we're starting with just one reactant and breaking it down into more than one product. All right. And so in this case, this is the reverse of synthesis, which is decomposition. And if you'll notice, these reactions haven't been, balanced or completed yet. So don't worry about that. We're just trying to practice identifying the types of reactions. Okay, so what we're going to ask you to do now is kind of pause the video and finish the practice problems, kind of 3 through 15 there. Then, once you're finished giving those a try, kind of restart the video, and it should go to the answer key next. All right, and so here's the answer key when you're ready. Zoom out there so you can see it. And again, a copy of this is on Google Classroom, so it's a little more readable. All right, but again, you can pause at this point and check your answers. And again, if you have any questions, make sure to let me know. Thanks so much, guys. Have a great rest of your day.